Alright, this is the 2015 AP Physics 1 FRQ number 4. So what we have here is a classic physics demo that we did in class. So we have one sphere is going to be dropped, one sphere is going to be launched, right? And I guess they're not even asking you which one's going to hit the ground first. They're both saying that they hit at the same time. They just want you to talk a little bit about it. So the first thing we're going to do is draw the FBDs, labeling the forces exerting on its sphere at Tf/2. So basically at the halfway point, right? That would be, this one would be right here. We know this one's going to follow the same rate. So that one would be right there as well. And well, we know that they both have equal forces, and they're both the force of gravity. So yeah, that should be it. Air resistance is negligible. We don't have to worry about that. So we can just call this Fg on sphere A and Fg on sphere B. Okay, that was easy. Question B, find the horizontal component of sphere A as a function of time, right? So, you know, again, this is a classic thing that we've talked about. So sphere A has no horizontal velocity at all. So it's just going to be a nice horizontal line, whatever you want to call T final. Just call it right here. And sphere B, this would be A, right? Sphere B is also, it has a constant horizontal velocity. So this would be sphere B. Okay, remember only the vertical components of velocity change when it's in the air. All right, explain why the spheres reach the ground at the same time. So this one, I'm not gonna write out a paragraph. Instead, I just hit on some of the points that you want to make sure that you touch on. So refer to the answers that you use in part A and part B. So we know that they're going to hit because basically, so some of the things you want to hit on is that the horizontal and vertical components are independent. So you want to make sure you mention that somewhere in your response. You want to talk about the fact that the vertical acceleration is the same for both. The vertical distance is the same. Okay, they're both falling in the same distance, so knowing that since they both have initial vertical velocities of 0, acceleration the same, distance is the same, then therefore time should be the same. And different distances. So somewhere you want to probably talk about the fact that even though B travels farther, it has a greater velocity. And because of that, well, they just kind of, that cancels each other out, right? It becomes a wash. And so therefore, yeah, so the time would be the same. So even though it's going farther, it's traveling faster, and therefore the time would be the same. So you want to make sure you hit on some of these components, and then you'd want to write out a paragraph that's coherent, right, and kind of explains these ideas. All right, I think that's about it. Thank you.